Hello students, so today in this video we are going to learn how to derive the expression for speed or velocity of the electron present in the nth orbit of a hydrogen-like species. So before moving further, let me explain you what is hydrogen-like species. As I have explained in my previous videos also, hydrogen-like species means a uni-electron or single electron species. So it is uni-electron or single electron species. So for example, some uni-electron species I can write as hydrogen atom because it has only one electron, helium plus ion because helium has only two electrons, so helium plus will have only one electron. Similarly, Li double plus ion, beryllium triple plus ion, and so on. So all these species are example of uni-electron species. And as I think you know that for uni-electron species or single electron species, you can apply Bohr atomic model. So we will apply Bohr model to find the speed of the electron in the nth orbit. So we will use Bohr model. So very important postulate of the Bohr model that says that electrons revolve only in those orbits in which their angular momentum is whole multiple of h upon 2 pi. So mvr is equal to nh upon 2 pi. This was very important postulate of the Bohr model, which makes it quite different from the Rutherford model. So we will use this postulate to find the speed of the electron. So without any delay, let's move further. Suppose we have a hydrogen-like species where the atomic number of the nucleus, that is Z, so total nuclear charge will be plus Ze, and around this nucleus there is a nth orbit of electron. So this is nth orbit, means principal quantum number for the electron present in this orbit, that will be small n. So this is electron, and suppose this is moving around this nucleus with speed v in the radius r orbit, and mass of the electron is m. So before moving further, I would like to tell you that in this derivation you already need to have the expression for radius. For that you can refer my another video where I have derived the expression for the radius of the electron in the nth orbit. That radius expression you can get, that is epsilon naught n square h square, and this whole thing divided by pi m z e square. So this is the expression for radius which we will use. Now we will use the Bohr model. Bohr model of atom says that mvr is equal to nh divided by 2 pi. So we can put the radius expression here. So it will be mv into r is epsilon naught n square h square divided by pi m z square. This is equal to nh divided by 2 pi. So from here you can cancel this m and this m. This pi will also get cancelled with this pi, and anything else, this one n and one h will also get cancelled with this nh. So what do you have now? Finally, v is equal to z e square, and this whole thing divided by 2 times this epsilon naught n h. So this is the final expression for the speed of the electron in the nth orbit. Okay, so very important conclusion from this final result you can have that velocity or speed of the electron in the nth orbit is directly proportional to z divided by n. So more the nuclear charge, higher will be the speed of the electron in a specific orbit, and for a single species velocity is inversely proportional to n. That means if as you move further away from the nucleus, speed of the electron becomes slow and slow. So far electrons from nucleus, they move slowly as compared to the closer electrons from the nucleus. Okay, so this is also important result you should remember, and you can see that if we put other constant values in this final result we have got, so we will have z is not a constant into electronic charge is 1.6 into 10 raised to the power minus 19 coulomb, it's a square. This whole thing divided by 2 times epsilon naught is also a constant, 8.85 into 10 raised to the power minus 12 in SI units, into n is a variable, and h is Planck's constant 6.626 or 6.6 into 10 to the minus 34 joule second. So if you solve this, you will get v is equal to 2.1 into 10 raised to the power 6 into z divided by n, and this will be in meter per second. So this is the expression for the speed of the electron in the nth orbit of the hydrogen-like species. So using this final result, you can calculate the speed of the electron in any orbit for any hydrogen like species just by putting the values of Z and N. So I hope you understood this expression derivation and you also enjoyed this video. If you are liking my videos, you can like my video and you can subscribe my channel and share these videos with your friends also. So next time we will again meet with some other kind of interesting proofs. Till then, take care, bye bye, and thank you very much.